Welcome to The Explainer. Today, we're jumping into a topic that every Go developer has an opinion on: code generation. Is it a lifesaver that boosts productivity, or is it a sign of bigger problems? Let's find out.
Okay, yeah, that pretty much sums it up, doesn't it? Code generation definitely has a bit of a reputation, but I'm here to argue that when you use it the right way, especially in Go, it's an absolute game changer for getting rid of that repetitive, error-prone work we all hate.
So, here's our game plan. We're going to start with the problem, the pain of boilerplate, then look at Go's built-in solution for it. After that, we'll see how to apply it to API development and wrap up with the latest tools and best practices you can start using right away. We've all been there, right? That soul-crushing moment when you realize you're just copying, pasting, and tweaking the same chunk of code for the 10th time. It's not just boring, it's dangerous. This is where the sneakiest, hardest to find bugs love to hide. So check this out. On the left, you've got this nice, clean product struct. But what if you need to handle partial updates? Well, a common pattern is to create a whole new product change set struct, where every single field is duplicated just to make it a pointer. Now imagine doing that manually for a type with 20 fields. It's just asking for trouble.
And that's really the heart of it, isn't it? This isn't just about being lazy or saving a few keystrokes. It is all about shrinking the surface area for human error. A machine doesn't get tired, it doesn't get distracted, and it definitely doesn't accidentally type purse instead of price. It just makes our code safer. Okay, so we've established the problem. What's the Go way of solving it? Well, instead of giving us some huge, complex build system, the Go team gave us something beautifully simple and explicit: Go Generate.
Now, this thing has been around forever, since Go 1.4, and its real beauty is what it's not. It's not a replacement for Make. It doesn't try to manage your whole build process. It does one thing, and it does it well. It finds a special comment in your code and runs the command you told it to. That's it. And this is literally all it takes. You drop this one line, the magic comment, into any of your Go files. It has to start at the beginning of the line, but that's the only rule. Simple, direct, and right there in the code where it's relevant. This slide really gets to the core of how you're supposed to use it. It's a tool for you, the developer, not for the people using your package. You have to run it yourself. It's not part of Go build. And this last point is crucial. You check the generated files into Git. That way, anyone who clones your repo has the complete code, no tools required. Okay, so that's the tool. Now let's put it to work on something we all deal with constantly: writing the server-side plumbing for a REST API. This is where code generation really shines. The modern way to do this, and honestly the best way, is called spec first. You start by defining your entire API contract in a standard open API file. Then you point a tool at that file and let it generate all the boring, repetitive server code. All that's left for you to do is the important part: actually implementing your business logic. And probably the most popular tool for this in the Go world is OAPI CodeGen, and for good reason. As Eli Bendersky says here, the code it produces is just simple and clean. That's exactly what you want from a generator: something that helps you out, then gets out of the way. So what does this actually give you? It gives you a Go interface, a perfect representation of your API spec, and it generates all the glue code to handle routing, request parsing, and validation for popular frameworks like Echo, Jin, or Qi. Your only job is to write a struct that satisfies that interface. The boilerplate just evaporates. All right, so we've got our generator. Awesome. But how do we manage the generator tool itself? This leads us to a really fantastic and pretty recent improvement in the Go ecosystem that just cleans everything up. The old way. Anybody who's been doing Go for a while remembers the tools.go pattern. It worked, but let's be honest, it was a hack. It polluted your go.mod file with dependencies that weren't actually part of your application. But now, thank goodness, with Go 124, we have a proper first-class solution: the tool directive. And switching over is it's so easy. Make sure your go.mod says you're using Go 124, run go-get with a new -t flag, and then you just update your generate comments. Instead of that long, clunky go run command, you just write go tool and the name of the tool. It's so much cleaner. But here's the real kicker. It's not just about a tidy go.mod file. It's about speed. We're not talking about a small improvement here. We are talking more than 10 times faster on subsequent runs. That's because GoTool is smart enough to cache the compiled tool binary, while the old Go run pattern had to recompile it from scratch every single time. It's a huge quality of life win.
Okay, so let's put a bow on all this. What are the key rules you should follow if you want to bring this workflow into your own projects, like today? At the end of the day, it's all about treating your generated code as a first-class citizen of your repo. Check it in, put a big do not edit header on it so nobody gets confused, and, this is a big one, add a step to your CI pipeline to make sure it's never out of date. And, of course, if you're on Go 1.24 or later, you should absolutely be using the new Go tool directive.
And this brings us full circle, right back to that Thanksgiving dinner argument. While these tools are incredibly powerful, it's always worth asking this question. Sometimes the answer is no, this is just boilerplate. But sometimes the need for a generator can be a hint that maybe, just maybe, there's a simpler design waiting to be discovered. It's a great question to ask. It keeps us honest.